In this lesson, we will discuss the graphical interpretation of sets of linear algebraic equations. Here we have a system of two linear algebraic equations, 2x1 plus 1x2 equals 4, and 1x1 plus 2x2 equals 5. If we solve both equations for x2, we obtain x2 equals negative 2x1 plus 4, and x2 equals negative 0.5x1 plus 2.5. Notice that both equations describe a line with x2 being the dependent variable and x1 being the independent variable. In the first equation, the slope is negative 2 and the y-intercept is 4, and in the second equation, the slope is negative 0.5 and the y-intercept is 2.5. If we plot the two equations on the same graph, the point where the two lines intersect represents the solution to x1 and x2. This point is 1, 2, so x1 is equal to 1 and x2 is equal to 2. When a system of linear algebraic equations consists of three or more equations, a similar concept applies, but the geometry is a bit more complicated. There are some sets of linear equations that do not have a single solution. For example, let's examine the following two equations. 1x1 plus 3x2 equals 5, and 2x1 plus 6x2 equals 10. The second equation is just the first equation multiplied by a factor of 2. If we solve both equations for x2, we find that both equations are identical. x2 equals negative x1 over 3 plus 5/3. If we plot the two equations on a graph, they would completely overlap. This means that any point along this line will satisfy both equations, such as 0 5/3, 1 4/3, 2 1, and 3 2/3. It is also possible to have a set of equations that yield no solution, and we call these systems singular. Here we have the same two linear equations, except the constant on the second equation has been changed from 10 to 9. When we solve both equations for x2, we find that the slope is the same for both equations, negative 1/3, but the y-intercepts are different. For the first equation, the y-intercept is 5/3, and for the second equation, the y-intercept is 3/2. If we plot the two equations on the same graph, we would find that they never intersect. In this case, no value of x1 and x2 will satisfy this set of linear equations. It is possible to predict whether a system of equations is singular by examining the determinant of the A matrix. The determinant will be discussed in a subsequent lesson.